Welcome to everyone. I'm Stefano Menapace. I'm a volunteer of the PMI Northern Italy chapter and the project manager of this event. Today, we'll hear 6 speeches about lean methodologies applied to the construction sector, with a particular focus on the digital tools in order to create value. Why this event? Well, nowadays, the construction sector is in need of innovation for its negative impact on the environment and the lack of efficiency. In this event, of course, we'll focus on the latter one, the efficiency, in order to give some insight to professionals to help them in closing the productivity gap of construction when it's compared with other sectors, for example, the manufacturing. In the productivity context, the management is more and more recognized as the real driver to create value. Why that? Well, because it makes the processes more efficient with the consequences of reducing waste as a consequence, not at aim. Within this vision, the role of the project manager is lifted from an operation to a strategic level, with a continuous need, of course, of new and more complex skills. So that's the reason why today, in this event dedicated to the construction sector, we see how to use cross-fertilization from different sectors. For example, again, the manufacturing, but not only from that. And how to properly use digital tools, which, to be specific, by the way, they still remains tools. They're not the aim of our work, not the aim to be digital. The aim of our work is always create value. So let's start. The program of this event has remained the one published, as you can see, and I'll introduce you the speakers on the way. We want to invite you to ask questions because we would like to start a confrontation among speakers and attendees on these topics. You can write the questions in the question box. You will find the question box in the control panel of GoToWebinar, right? If it's possible, please avoid the chat box. So next, our volunteers, Oreste and Matteo, will submit them to the speakers during the 2 questions time planned. Okay, but before to start with these speeches, I would like to thank our sponsor, Climacenter. Climacenter, let me introduce them, is a small, medium enterprises firm in the north of Italy, which develops high-level details BIM model of heating, ventilation, and air conditioning, and thermohydraulic systems, and provides the complete installation for high-quality and certified staff for mechanical and electrical systems. Thanks to their experience and deep use of digital tools, of course, such BIM, integrated in their operation, they are able to cut down site timing and reduce unpredictable interfaces. I would like also to thank Fraunhofer Italia, today here with 2 speakers, and we hear them later, for their scientific support in this event, and Ordine degli Ingegneri di Gorizia, which they give their patronage. Right. Let me introduce you now the first 2 speakers from the University of Bergamo. I invite them to switch on the camera. Okay, here they are. Paolo Gaiardelli, Associate Professor of the Department of Management, Information and Production Engineering of the University of Bergamo, Italy. His teaching and research subjects mainly concern operation and production management with a specific interest in lean management. Matteo Zanchi, engineer, PhD student, and research assistant at the University of Bergamo, Italy. They will introduce us to the lean methodology and lean construction. So, Paolo and Matteo, the stage is yours. Right, we see your presentation. You can start.
Okay, thank you very much, Milite. Thank you, and I would like to thank the organizer to have this opportunity to introduce my point of view and the point of view of my colleagues, Matteo, on the application of the lean management in construction, a subject that we have recently addressed thanks to the funded research projects carried out with some local companies operating here in Bergamo area at different levels of the construction process chain. Let me start with a general consideration, not specifically related with construction, but rather concerning any modern business. Today's customers have become particularly demanding, and the market needs is a combination of growing requirements in terms of different value dimensions. These requirements are sometimes in contrast, making it difficult to accommodate such different objectives. Ensuring reliable processes and near instantaneous responsiveness on high performance products, adapting to changing market needs in an increasingly efficient manner is not an easy task, actually. In this context, lean management approach has been recognized as one of the most effective methods for maximizing efficiency, productivity, and flexibility, attracting growing interest in academia and industry. Based on the principle of doing more with less, the aim behind this the adoption of lean practices, is to create processes that require less human efforts, less space, less capital, less time, and less energy than traditional management system to produce products or services, so that companies that develop such an organizational method are able to respond to customer needs with greater flexibility and elasticity. Efficiency is achieved by eliminating or reducing, where it's not possible to eliminate, all non-value activities, so that each process is shaped to create value for the company, for the customer. Acting on one or more wastes, the so-called muda in Japanese, of which category we have given some example here in this slide that are related to the construction sector. So acting on these wastes brings benefits, as the wastes are mutually dependent on each other usually. And for example, reducing redundant activities can generate a decrease of unnecessary movements and transports, which in turn leads to a decrease of overloads on the one hand and waiting time on the other. Again, lower overload means lower risk of producing defects, and as a consequence, they're producing more than necessary to make up for existing deficiencies. Applying lean management effectively involves the adoption of a set of practices for efficient workers organization based upon process standardization first, process synchronization second, and process simplification third. Also through the use of visual system to ease the information flow within the whole organization or the whole supply chain. This is not enough. Indeed, lean is recognized as a socio-technical model based on the principle of continuous improvement and the search of perfection, to be pursued in the long term through simple but frequent daily improvement actions. Value for customers can be achieved through the application of specific technique together, but always sharing goals and the efforts within the organization, as the drive of innovation in this case is the integration of skills and aptitudes of individuals whose specificities following lean principle should not be repressed, but rather enhanced and expanded. As reported in this slide, if a company succeeds in acting this way, so taking in a comprehensive view all of these aspects we have just spoken about, it can achieve, so the company can achieve advantages that translate, operational advantages that translate into organizational and strategic business benefits, as many examples of success, but also unsuccess, have suggested in the past. Given the success and popularity of lean management approach for optimizing activities, primarily in the manufacturing sector, but also in other contexts ranging from agriculture or public sector, but also involving logistics and transportation, and covering different phases from design to operation until after sales, the question that has always been whether such practices could also be extended to contexts not characterized by large volumes and linear processes, such as in the construction industry. Actually, and well, characterized by obvious performance issues related to cost, delivery defects, safety that predict the considerable margins that can be pursued through the adoption of process optimization, the construction sector is potentially well suited to the adoption of lean practices and initiatives. The graph here reported just provide in a clear way how the sector is characterized by a lot of waste, definitely higher than in manufacturing, where lean management was born and has found great success. And this suggests that the sector could benefit enormously from the adoption of lean techniques. Nevertheless, we are assisting, or we are operating in a very complex sector with specific particularities that distinguish it from a classical and classic production environments. Indeed, it's not objects that move between the teamworks in construction, but the work team that move between the objects and the items. Each project is different from the others. Operations are often simultaneous and recursive and require synchronization. The processes are variable, involve several internal and external actors, and the final result is often influenced by external factors that cannot be controlled, such as weather conditions. So this suggests that the application of pure system or methods, or the pure replication, I would say, of the same tool that are adopted in other industries, specifically in manufacturing, could not generate satisfactory results. So lean tools require to be modified and adapted to this specific context. Hence, the need to develop an original model adhering to the specifics of the construction complexity and complementary to the classical lean approach. The Lean Project Delivery System, or LPDS, is a framework developing research to express the ideal construction project delivery process and supporting the identification of a proper set of lean techniques and tools to improve efficiency at different phases of the project delivery, in order to first develop individual processes without waste, second, implement a flow logic even in a recursive context such as a construction, and third, instilling the ability to react to internal and external changing conditions. In other words, we can say that LPDS sets the condition for the creation of a project that is structured and managed as a value-generating process, involving various stakeholders at any and since the beginning of the early stage of to plan and design the project phases through cross-functional teams, and adopting pool techniques to manage the flow of information and materials between stakeholders. On these premises, I will now leave the word to my colleague Matteo, who will go into detail on how and in what way we can implement the LPDS. The floor is yours, Matteo.
Thank you. Okay, thank you, Paolo, and good evening to everyone. To make sure that the conditions for the creation of a project structured to generate value are encountered, it is essential to fully understand the process and the different criticalities inherent in it, so as to act directly on the upstream causes of waste and, if necessary, go back to the planning and design phase with the intent to develop a responsive planning ready to deal with the changes due to internal or external causes. Similarly, reducing the recursiveness of individual project phases is critical to ensuring that time and cost constraints are met. To do so, there are several lean tools specific of each aspect that can help increasing the value of the building process. Briefly reported here, and that we will see in detail in the next slides. Value stream mapping is a mapping method derived from the lean tradition, and it is used to depict the current and future or ideal states in the process of developing implementation plans to install lean systems. As you can guess from the name of the tool, value stream map mainly focuses on the representation of the value stream, or in other words, all the actions currently required to bring a construction site up to the completion phase, which is the main part of interest for our customer. BioStream map consists essentially of 3 different kind of flows, which are recorded in the slide: the information flow, the physical flow, and the time flow. BioStream map is in fact an essential tool whenever it comes to start a lean journey, as it helps visualizing more than just a single process level in the production. We can see in fact the workflow of construction. It also creates opportunities to search for critical issues, and by so it helps to see more than waste. Mapping in fact helps to see the sources of wastes in the value stream. It also provides a common language and a common basis for ideas and knowledge share. BioStream map also becomes a blueprint for lean implementation, as it helps design how the workflow should operate. Depicting the current state map, though, is just the starting point. Designing and introducing a lean value stream through a future state map is indeed what matters the most. The purpose of BioStream map is to highlight sources of waste and eliminate them by the implementation of a future state value stream that can become reality within a short period of time. One of the first approaches that is used on a regular basis whenever a lean process is being undertaken is the 5S methodology. Born in the manufacturing sector, this method has also found widespread positive feedback in the construction industry, as the usefulness of the tool to reorganize working areas touches a high critical aspect typical of construction processes, where usually order and standardization of space is certainly not very common. The 5S methodology is structured into 5 different phases, which you can see in the slide. And these are: sort phase, which is the removal from the workstation of everything that does not serve the ongoing construction process. Set in order, the efficient arrangement of tools, equipment, and materials so they are immediately available when needed. Shine, or in other words, controlling the order and cleanliness created by checking for and eliminating problems. Standardized phase, and maintaining the order and cleanliness created through the creation of standards. And finally, the sustaining phase, which is making the procedures a habit and maintaining them over time through a strong discipline. The strong success of the 5S methodology is specifically due to their ability to, first of all, ensure healthier and safer working conditions. Second place, making the work environment more pleasant by encouraging teamwork. And it also encourages the standardization of work, also through the principles of visual management, for example. It also optimizes travel by reducing distances and traveling time, supporting the adoption of further lean techniques for the proper management of material. With regard to the management of materials in the construction site, in the lean context, one of the most used tools to ensure a correct and timely management of materials in order to avoid waste due to excess of stocks, with the consequent generation of unnecessary waiting for material in the site of overproduction for the processing of excess material, is the so-called Kanban. Kanban literally means visual signal, and is a lean technique for the circulation of information in a systemized manner within the worksite, or possibly also between the worksite and the suppliers, based on physical tasks that authorize the production, purchase, or movement of materials. These slides show an example of supply of materials regulated through the Kanban. In particular, we can see 3 different areas in this slide. The first one referring to the internal material flow through a production Kanban. The second part on the left, the external material flow through delivery Kanban. And the third one represents the replenishment process of Kanbans, which sum the work process. Another tools that lean construction has is the last planning system. Last planning system aims at increasing the reliability of planning and thereby improves performance. Increasing plan reliability is done by taking action at several levels in the planning system, which are represented in the cycle that is represented in the slide. So the first phase is the master schedule, which initiated the strategic planning, where the major milestone dates are identified and the specific time between the various phases a project goes through is defined. Milestones are also defined on the entire project length, and so master planning provides a long planning horizon. Phase scheduling, the second part, generates a detailed schedule that evolves during the project by exploding the master schedule into smaller and more detailed project components. In this phase, hands-off between different phases are evaluated, often resulting in modification to the previous plan. Tasks are now in fact defined and sequenced so that their completion releases work. Look ahead planning, which is the third part of the last planning system, is a list of activities that need to be worked on over the upcoming weeks, usually on a window of 6 weeks. Look ahead planning details and adjusts the schedules, pulling a resource into play and screening activities for which resources are likely not to be available. Plan here is updated on a weekly basis and constraints analyzed on a weekly basis. Weekly work plan is instead the most detailed plan in the system, and it directly drives the production process. Plan reliability at this level is promoted by making only quality assignments and reliable promises, so that the production unit will be shielded from upstream uncertainty. Learning is our last phase, and it consists in analyzing reasons for plan failures and acting on these reasons. To do so, the last planner needs a performance measure to gauge the quality and reliability of each weekly work plan, typically through the use and measure of a personal plan complete index, representing the number of actual completions divided by the number of assignments for a given week. However, an effective schedule does not work if the project is sprung from the beginning. Developing a lean project goes beyond a proactive planning approach. To be such, a lean project delivery system should involve cross-functional teams of stakeholders since the design stage to the creation of an optimized asset lifecycle, from planning to implementation, management, and release. Now I'm giving back the floor to Paolo, and thank you all.
Thank you, Matteo. Just to conclude this presentation, just with a few other considerations. So based on what we have understood, so we have different levels of techniques and methods. The methods can be in lean construction, can be related to specific processes, can be related to the proper reorganization, planning, and controlling, or can be related to managing or anticipating problems from the beginning or from the early stage of design. However, we should not forget that was we initially affirmed, namely that lean management, even in a construction context, cannot be reduced to a proper set of techniques and tools. But success can be achieved only taking account long-term orientation, pursued day by day with participation of everyone. This is now our opinion and the opinion of experts, the key points of any lean application. Experience shows that even if all lean construction tools are properly introduced according to the dictates of LPDS, success will never come about if improvement is not seen as a process to support learning and cultural change of the whole organization, from the top management to the workforce. In conclusion, I'm summarizing these 10 messages taken from the experience of many companies that have already applied with success sometimes and with unsuccess many times. In management, and they apply lean management, we can say that lean management is certainly feasible in a particular context such as a construction, but to be truly effective, it needs to be rethought in respect of the distinctive characteristics of the sector itself. It means that traditional techniques are applicable, but nowhere actions are not replicable. Here the focus must shift from a perspective of incremental improvement, typical of lean manufacturing, so incremental improvement of process to a perspective of an incremental improvement of its management system. So it means that the activity is not standard, but the approach with which we plan and control it can be standardized. This is the case of the Last Planner system, which aims to improve the productivity and at the same time the sense of responsibility of workers through rigorous and detailed planning based on a new form of predictable scheduling. And where even the nature of action remains inherently collective, responsibilities are assigned to ensure that each worker is directed to complete his or her task on time. Indeed, experience shows that success occurs when there is a full achievement of people. The most significant and relevant results do not depend on the type of process involved, but as we observed, on the orientation of people towards such an improvement. Indeed, the projects that have given the best results are those in which the management has shown itself to be proactive, to be supporting, to be respecting, just creating the ideal condition for relaxed environment in which the work group feels free to express itself and get involved in process optimization. With this, I've completed my, finished my presentation, and thank you very much all for their attention. Thank you.
Thank you. Thank you very much, Paolo and Matteo, for your valuable introduction on the topic of this event. So let's go on. Our next speaker, which I ask him to switch on the camera, is Luca Martinello. He's senior consultant at the Istituto Lean Management, part of the Lean Global Network. He has been researching lean management and lean construction since 2006. He presented some case studies of lean construction applications, which it's really interesting to understand the potentiality of these methodologies applied. So, Luca, thank you. The stage is yours.
Here I am. So, welcome. I'm Luca Martinello. Sorry. Yes, I'm a senior consultant of Istituto Lean Management, and we work to our mission is to develop lean thinking in our countries. Our approach is to develop capabilities and teach people to apply lean in their daily life and work. We are currently doing some activities in Italy, and we have two main approach. The first approach is project-based. That means that we work directly on projects with different companies, trying to apply lean on a project. The second approach is deeper and is basically concentrated in transforming construction companies and companies involved in the entire construction supply chain to become lean, and so to be more effective in the end in the application of lean concepts on site. This is related, if we think about the first presentation, this is related to the change in terms of culture beyond the simple use of tools. I'm going to, sorry, yes, I'm going to provide you a case study related to the tool that has been presented before, which is called Last Planner system, that we are basically starting to use here in Italy. We are very few experiences at the moment, but it's becoming rather common around the world, in England, in the United States, in Germany. This system, as it has been explained before, it's a system for the planning and the scheduling of the construction site, And I personally think it's quite effective because it brings together the two words, like the traditional CPM approach with the agile approach on site. This system is basically built around the concept of developing planning and scheduling as you go during the construction site, increasing the level of detail in the planning along the five phases, 5 steps of the system, which start from the milestone planning. Then that can be often be connected to the general project schedule. Then there is a second step that is phase planning, where basically we take a milestone and we develop a proper program of a specific phase of the construction project. Then there is a third part where we basically make ready work, basically reduce risks and increasing reliability of the program. Then there is a weekly work planning, where basically where we have a very detailed program of the week, and then there is a set of tools that allow for measuring performance and learning what's working and what's not working with the project, so that we can control and activate a system to improve results as long as the project progresses. So to control risk mainly. The first case study that I'm going to introduce you is a project that has been done by one of our clients, Riccesi Holding in Trieste. We've trained project managers of this company, Michele and Nicola Pecchi, to basically use these tools, this system. And this is a typical project in Italy, so a very small dimension, like 2 million euro. It's a school, and as any project, it has many subcontractors, stakeholders that we need to coordinate. How did we introduce the system? I'm strongly convinced that lean becomes effective when it is used by the people actually controlling the process. So we need to have simple visual tools that allow for collaboration on site. So during the pandemic time, where we couldn't actually meet in presence, we developed this program where basically we have been providing, we had like very small classes. We basically provided 4 hours training. Then we were asking the participants to choose one of their projects, and this company chose the school that we are talking about. And we asked them to develop phase planning during the first week. Then after the first week, we get together again, all the companies involved in this training, and we basically exchanged comments about the experience, a sort of peer review, and there was a chance to provide coaching on the application of the project. And then we allowed the companies to go back to their construction site, and we asked them to basically use another part of the system to develop it, and then back again the third week to provide coaching. So basically, we developed this training that was centered in the main idea was we train you, and you start to use the system in one of your projects. So this project basically started with this training, online training. So now, what do you see here? This is a phase planning. We do it rather a little bit differently from the general guidelines, but we found this way very effective with our companies here in northern East Italy. Basically, the phase planning is an activity that you see. You involve all the subcontractors. You put them together in a room. You give them each a color. So let's say you have the gypsum board is yellow, the carpenter is orange, the mechanical is green, the electrical is blue, and so on. And then you share with them a target, so a milestone that we want to respect. And all together, we try to find the best process, so that to make sure that we meet that deadline, that milestone. We do that dividing the whole project, and this is the plan of the school, into areas. So we have a location-based approach, where basically that we basically put along the lines. So on this big sheet you see lines that are areas of the project, and the columns are weeks. So if you follow one line, you basically understand what will be the process in that specific area, who will be working, and in which sequence. It's like putting a camera on an area, and if you follow the line, you see what is going to happen in that area. And we do this on a weekly basis. So we're not really interested in getting activity duration exactly, because we know it's very hard to estimate activity duration. But we are very concentrated in understanding the process that we will have in that specific area. Generally, in a project that last, in this case, was a couple of years, but we try to cut the project into phases, 3-4 months phases, and every phase we meet together with the subcontractors, the subcontractors involved in that phase, and we develop a shared plan. This is very important because project managers don't have all the knowledge. So by doing this, you really take out knowledge from all the people involved in the process, and what you basically do is a very reliable program. And by doing that, the subcontractors understand the problems and make the programs for themselves. After this first phase, so basically we do this once every 3-4 months. So one time for one phase. We go to a second level that we call look ahead and weekly work planning. Basically, we develop this plan that is weekly, based on weeks, is exploded into programs that have a daily they're basically based on a daily base, and we basically have 6 big week plan, and we develop every week we develop one additional week. So basically we do something that we call rolling. So let's say every week the first week you develop a program for 6 weeks, and then every week all the staff of the site meets together and share and revise the program for the 6 weeks for the 6 weeks, the future 6 weeks, and this is very interesting because you see the problems coming. Why 6 weeks? Because in 6 weeks times, generally you have the capability to solve most of the problems, like having approval on a product. You can basically have most of the materials delivered. Long lead time materials are actually considered in the phase plan. And with this process, you really control activities on site. And this process, we keep it always location based. This is a very visual way to see how work will develop, and it's very easy to control. Every week we're going to froze the week after. So we say during the weekly meeting, this is going to be the plan of next week, and the week after again, we basically control how good we were in respecting the plan that we had set 1 week before. In this case, we measure a KPI, key performance indicator, that is called PPC, plan percentage complete. And what we know is that when the reliability of our schedule is high, we have less waste on site, because you don't have crews that expect to do something and they can't do that, and they move to another area of the project, so they don't move. Basically, generally people, when they know what they have to do, they have all the tools, they have all the materials, really productivity increases. The nice thing about having the look ahead and the weekly planning is that you can visually control where you are, and if you are going, you have some delay, because for example, here in this week, you see that we are supposed to have green and purple and blue activities, and if you look the detailed plan for the same week, you can easily see if you are respecting the plan. So basically, the phase plan works as a baseline. So this is the setup. This is our actual picture. So this is the phase plan, and these are the 6 week plans. These are the companies involved. These are the areas of the building. And here, basically, there was the company was basically doing one meeting a day, and was also to check how they were actually respecting the program, the weekly work program. And also they were having a weekly meeting where they checked the results of the program of the week before, and we're adding detailing another week 6 weeks in advance to check for problems and things to solve to make the program reliable. What are the feedbacks from the people using these tools? So from the actual project managers, we basically aim to make project manager life easier. So what they said was that with this system, they have better and real-time fresh information on subcontractors' critical issues affecting actual works on site. Sometimes just knowing that some material will not arrive can help you changing the program so that the delay of one subcontractor doesn't affect the activity of another subcontractor. The system making information visible increases team feeling and collaboration between subcontractors. Looking in advance, 6 weeks in advance of activities that will happen that week makes easier to organize on-time delivery for materials. you definitely have better coordination on site, both in terms of less conflicts between the different crews and better workflow. And all this productivity, when you work very well, when we say noise goes down in the construction site because the activities flows, then you see actually a lead time reduction. So we see that we tend to be always in advance of on our schedule, and that visual that making visual the areas also makes very easier to see opportunities for fast tracking the project, to make things in parallel. And definitely the system allows you for better control and monitoring over activities duration and deadlines. And when you see that you are running late, you start basically you have the opportunity with all the crew, with all the staff of the site to go and attack the problems before it becomes too late to solve it. What are the key learnings? Well, the project managers in this project said that they had a big satisfaction to see subcontractors looking forward to the meeting to solve the problems. They were very happy when the subcontractors came and said, "Hey, are we going to meet?" It definitely helps the superintendent to be in control of activities on site because it helps you having control on what happens. It definitely improves time management, personal time management, project managers. If I would, I'm from this world, so I work as a project manager on site, and I would definitely use this system because it makes easier to have everything under control, and it makes it easier to create a team on site to address problems. This system avoids you as a project manager being a bottleneck in the flow of information. So the visual support, the routines, the weekly meetings allow for people to exchange information without necessarily go through the project manager. And it's very useful to guarantee steady work on site. We have experienced in many sites, also especially for MIP subcontractors. And the project manager said that I'm convinced that the system has strongly improved my capability to solve interference on site. When staff works better, it reduces their time to do things, and reducing time, activity time, cycle time makes also total project duration shorter. I'm not probably my time is almost at the end. What are we experiences? Definitely, it's very important to what we need to learn at the moment in our sites is to be able to involve more and more the foreman in the process. We need to keep things simple to have people participating in the program. But we see that this is coming. It's very important to have the project managers, subcontractors involvement, because sometimes the foremen on site don't have the power to make decisions. So sometimes we need to involve also project managers in the weekly routines, and definitely it's very important to understand and use the time wisely during weekly meetings, so not to waste everyone's time. Definitely, these tools need a culture improvement. So people need to understand why we want to work like this. We need to share the same values and the same approach to the project. If you just take the tools and put it inside a company just like that, and the company or the entire team is not ready, tools cannot be effective. So I think my time has expired. Stefano?
Yes, Luca, it is. If you want, you have 1 minute to finish up.
Okay. Well, we're working also with another company, this Battistella. This company we're doing what you saw in the first project, but we're working also in the total culture and total reorganization of the company. This is another school, another case study. You basically here see the same tools that I've explained just before. So you see on the left is the master plan with the milestone, the phase planning, and on the picture on the right you see the different the weekly work plan. So the 6 weeks, 6 to 7 weeks that I was talking before. It's very visual. They have a weekly meeting, a daily meeting. And really, when you see that when the team starts working, this goes very fast. Also in this project, it's very good when you see foremen start thinking up to 6 weeks. You see that the activities be very prepared on site and the site accelerate. It's key to have people writing their own tags. So we use Post-it because actual people on site can participate to the process, and they take pride of the process and they take responsibility of what they say, and it's there. And it's a promise not in front of the project manager, it's a promise in front of all their partners on site. So this is very important. The project manager on this site said to me, I'm usually very worried when I go on holiday, but this year I really received very few phone calls. I was very surprised that the information, the site was really going without his support. And a good thing to say is that one morning I was late. I received a phone call from a subcontractor to check that the meeting was confirmed, because he needed to solve problems and understand the program. So when you say subcontractors, site foremen asking for the program, I think that according to the actual situation in our construction site, I think it's a very good sign that the system is powerful and is useful to help people work. So this is what we want. So again, this is our approach, and to support the use of tools, you need to have a culture, a lean culture in the companies, and a culture in companies where problems are opportunities. So you see people looking for solutions. You have management modeling good behaviors, looking for the root cause of problems. They don't go and look for guilty. This top-down culture. It has to change. You can't use lean tools if there is not a change in the culture, and there is a general idea that you keep trying, improving, and if it doesn't work the first time, it's not a waste. You're basically learning to work better and better. So I really thank you, and I finish my presentation here. Thank you very much.
Thank you, Luca.
Good evening to everyone. Thanks to the speaker for the presentation. And let's start with the question and answer session. For Paolo and Matteo, which is the diffusion of lean construction in Italy and the rest of Europe?
Sorry, can you repeat, please? We have not heard very well.
Which is the diffusion of lean construction in Italy and the rest of Europe?
Okay, so if I can say in a few words, I would like to repeat what Luca Martinello said before. So it's
sorry.
No, it's just to say that, so as Luca mentioned before, it's lean construction, and the application of lean is really well performed and adopted in America, in the United States, in the UK, or countries like, we know that for sure that in other area of the world, like in Emirates area, for example, is quite well developed, especially at research level. Considering research level in Italy, we have some research group that they are doing in activities in lean construction. But if we look at the perspective of lean construction in practice, probably because of the type of projects, we can find a very higher diffusion of these practices in the countries as I have previously mentioned, so North America, United Kingdom, so that specific area of the world. In Italy application, then Luca can give me his point of view. So in my opinion, our opinion, the lean construction is not so well diffused, probably because of the size of the projects and the size of the company that usually introduce this specific concept. I would say that typically, this is also typically in production and manufacturing, that the big companies operating in big projects that usually start with such a kind of approaches. Even we have these examples, Engineer Martinello just provided to us. There are some introduction of this application also in small medium enterprises, but I would say Italy is not so well developed as in other countries like UK and United States. I don't know if Luca can agree with my point of view.
Shall I reply? Or yes, I do agree. Definitely, we're at the beginning. We're working a lot with medium-sized companies because basically they are 90% of the Italian market. So if we want to address lean in Italy, we need to make sure that we understand how to bring these principles and tools with these kind of companies. We are currently having a very practical approach, and there is value in these tools, and that can be used by anyone, any project. The problem is that you can't really fully apply lean unless at some point you work on the entire project. So from design to construction. When we apply this system we are applying the system. We have applied the system in around 10 construction sites. Sometimes it works very well. Sometimes it gets difficult because there are major problems on the design side and on the budget side. So these are risks that you can't control. What you can control up to a certain point during construction. But in terms of actual site organization, really in terms of controlling the activities on site, helping people knowing where to go, what they have to do, when they need to bring the material on site. This is a very powerful tool that can be easily applied also in Italy, and it makes really life easier for project managers, site superintendents, and we hopefully we personally seen a very the interest in Italy at in this moment is increasing quickly from our perspective, from our point of view.
Thank you. And does Axis Digital tools to apply the Canvas tables tools we saw?
Is this a question for me, or?
Yes.
Sorry,
digital tools to apply the Kanban tables tools we saw?
Yes, there are many digital tools at the moment. Definitely, they would make life easier. There is also the risk of a big of wind to make your programs fly around on the post-its. But there is I think here there is a critical point. Lean is tools have to be easy and need to be used by people working on site, because they are made to give information to people. So if you want a plumber to take part to this process, if you want the gypsum board for foreman, if you want the guy that comes into your trailer with his hands dirty to understand what he's going to do the week after, you can't really now in Italy, I'm saying, at this level, in this type of companies, introduce too much digital instruments. For example, just to give you an example, I know that the system is working when the post-it in the barracks are written badly, when they are kind of hard to read, let me say, because I know for sure that those post-it, those promises have been done by people on site, working on site, that they have been involved in the meeting, they have participated in the process, and they have basically promised that they will deliver that work, and they have said that they have all the information, all the materials, all the things to do it. That is the sign that things are becoming reliable on site, and when things becomes reliable, people works better. When people works better, that takes less time. When it takes less time, project duration becomes shorter. So this is my point of view. But definitely in perspective, or with companies with higher culture, digitalization will be definitely very important, because one day, yeah. Well, this is my opinion, like from the ground. But right now, it would be a problem to use in these sites a digital tool, because that means that people would need to undergo a training to use a tool to participate to a process, and this is just too long. So people to participate to the last planner process just take half a day of training, and then they are in. They start working with that. That is very powerful. But again, this is my experience.
Thank you, Luca.
And can I have my point of view? So
yes,
I fully agree with the statement of Luca. And also, if we take a theoretical, I would say, perspective, because sometimes this is not happens only in construction. It's actually a whole context where you apply digital tools in leading. So we have a great experience, probably higher experience in manufacturing, but it's the same story, I would say. So if you look at digital tools can be applied, I would say, at the end of the implementation of the process, because otherwise people are more focused on the tool itself and not on the way they have to use the tool in order to help make easier their process. And so the focus of the organization from the methodological approach on optimization, so the last planner system, for example, to the tools adopted to. And so you lose the real value that is inside Lean. This is not the tool. The tool is something that's helped you improve or to provide better and quickly the processes. But Lean is another thing, is improve the process itself, making it efficient. I don't know if you understand what I mean.
thank you. Our time is up, but for last question, how can a value stream map describe the complex physical flow on a building site?
I think it's a question for us. So
I can reply. I would say that value stream mapping in a construction sector is really different from the manufacturing one. Originally, in the manufacturing sector, value stream map mainly focuses on the object itself. So, a more across the whole transformation of the object, since being a raw material up to being a final product. Meanwhile, clearly in a construction project, you're not dealing with objects and components. So, value stream mapping in this case actually has to focus more on the activities themselves and on the work of the different teams. So, like describing more in detail different activities that are already planned in the last planning system, for example. Furthermore, value stream mapping in the construction sector is more useful as in providing a common basis for knowledge and ideas shared. And also, it provides that chance that we're looking for to identify the different wastes inherent in our processes. So many times, value stream mapping, even being less useful than in manufacturing sector, gives us the chance to actually do the Genchi, so the Gemba, visit the Gemba, to see what is actually really, what's going on actually. And this lets us understand what are the main criticalities and what are the main solutions that we can take to solve the problem.
Thank you.
Thank you.
Thank you. Thank you, Reste, for the moderation of the questions. Thanks to the speakers for their answers. And of course, to everyone who asked a question. If we haven't time to answer to all the questions which they arrive right now, please feel free to write us. We will forward the questions to the speakers. Right. Before to go on, I remind you that the presentation you will see will be uploaded on the PMI Northern Italy chapter website. You might need or you might want them. Right. So thank you again for the speakers. And let me introduce you now the next two speakers from Fraunhofer Italia. Gabriele Pasetti Monizza, team leader of digital design and engineering team at Fraunhofer Italia and adjunct professor at the Free University of Bolzano, Italy, for the course Construction Site 4.0. And Cinzia Slongo, here, research in process engineering in construction at Fraunhofer Italia. They will present us how digital transformation can be seen as a challenge for boosting automation of the information system with a specific focus on the construction sector. Well, Gabriele and Cinzia, the stage is yours. Thank you.
So, thank you for the introduction, Stefano, and good evening, ladies and gentlemen. Thank you for the invitation for the organizer, let me say to the organizer. Let me start from a consideration. Neither Cinzia and me are masters in lean methods, or let me say expert in lean construction methods. So consider us that we are technicians. We are researchers that daily are working side by side with enterprises. So on another end, we use lean methods in facilitating the digital transformation within the building industry. So let me say that this evening we would like to offer you a different perspective, and let me say an applied vision of digital tools and lean methods within the building industry itself. So let's start from a provocation somehow. When we talk about the building or construction sector, it doesn't matter if you are focusing on just buildings or even on infrastructures and so on. So this sector is almost led by craftsmanship. And if you think since when the ancient humanity was looking for a shelter made by raw wood, made by something that they can catch in the forest, for example. So this perception is still valid today. So customization in building industry is a key factor. If we think buildings should be distinctive elements. For example, a corporate design or corporate images, sorry, of a company. Or for example, they should be a personal place to spend the life with my own family. So looking at the value chain system, as the previous speakers already discussed it, we can notice that it's structured to deliver a tailored product because it's a serial workflow. And this serial workflow somehow include different processes that are led by different leaders, but as well they are developed and delivered in different time slots. So this sequence is very rigid. And if we look at the trigger somehow of this huge workflow, we can say that maybe the building sector is an engineer to order industry, so which means that everything starts from the beginning to the design process. According to that, we can say that every building is almost unique, and it's almost impossible to find a building that is exactly the same of another. So maybe we can find similarities, we can find standardization, we can find whatever you may associate to something that is very similar to another, but is not exactly the same building. So as soon as we are going to introduce somehow an industrial approach in the building industry, we absolutely require to improve, obviously, the antagonist goals of variability and quality, because let me say from the beginning, we say that customization is the key factor in building industry. So we start that variability is something that is a conditio sine qua non, so something that has to be absolutely included till the beginning. But these goals, obviously, so are the success factor of the building industry. So on the other hand, if you would like to somehow improve economy and speed, we have to pay attention because they can become a market failure. So I think that all of us have a common picture of what prefabrication is. So every one of us, when we are talking about prefabrication, is thinking about, you know, this huge industrial building of these buildings coming from the 60s of the last century, for example, in Russia or in East Europa, in East Europe, where obviously all the buildings were prefabricated and strongly standardized. So we cannot distinguish anymore a kind of custom, let me say, features, or any way we cannot recognize something that is a unique aspect of that building. So it's important somehow that we understand that through digital technologies, we can avoid an overlapping of approaches, because we have to understand that industrialize, prefabricate, and standardize are not synonyms. So which means that an industrial model obviously is the condition for starting, so for applying prefabrication, for example, in building industry. And prefabrication is somehow the base of the industrial process, let me say, transferred to the building sector. But on the other hand, the prefabrication is leading the standardization level. So which means that we don't have absolutely to think that prefabricate does mean highly standardized building components. So comparing the building industry to the automotive, as a lot of people are doing right now, we think that it's a little bit reductive, because by doing so, we are introducing a paradox. A building, or a construction in general anyway, cannot be delivered as a finished product, as you can think as a car. So in the picture, we can see something that it's not feasible, for example, in any time or in any moment. So it's possible, obviously, to introduce industrial approaches on site or off site, but we have limits. So which are the limits of the prefabrication and which are the limits of the machinery and robotic application?
Thank you, Gabriele. It's not easy, in fact, to answer your question. Construction, in fact, aims to apply the principle of industrial automation to construction sector. But robotics in construction has not reached the level of other industries, like, for example, the automobile manufacturing. Robots, in fact, usually are best suited for repetitive tasks that occur in an environment that never changes and a constant environment. While construction present several challenges that are linked to the complexity and the variable nature of a construction world, and also because the environment is always changing, is unstructured, and also teaming and working with human is always required. However, some types of automation and robotic technologies are still going on, like, for example, the off-site automation. The off-site automation, like the factory organization of Sekisui Heim, that is based on an assembly production line in which the steel frame units were custom built on the customer preferences. Then these parts were assembled in blocks in the factory and then transported and assembled on the site. Another example is the on-site automation. Like the smart system of Shimizu Corporation, that is a sky factory moving upwards, supported by buildings. In this case, the roof structure is mounted and assembled at the ground and then lifted at the desired height where other operation can start. Finally, there is the single task construction robots. These are systems that are custom built for supporting the workers in a specific construction task, usually a repetitive task, like, for example, digging or concrete leveling, bricklaying, or paintings. So, as we have just seen, robotics give us the possibility to apply the industrial processes to construction. But in construction, there is the limit that some processes must necessarily be done on the site, and also the work of human is always required. So independently of the type of automation, there is a problem to solve, because whether we are working with humans with their flexibility or with a robot with their efficiency and accuracy, there are different types of information that are required at the different stage of the work progress. So the key problem, the key issues is how to handle information when and where is needed.
Yeah, Cinzia, I think that it's fundamental somehow to understand the value of the information in the building industry. So before or earlier, we mentioned that the workflow in the building industry is arranged along a serial sequence of processes, let me say. And so this structure, anyway, may somehow lead to a propagation of error. What does it mean? It means that small neglections or mistakes at the beginning of the workflow may generate expensive and resource-consuming problems in late processes. Earlier speakers, also the speaker before me, also underlined that it's important maybe to start earlier during the design phase, not only on the construction side, applying lean methodologies, for example. But obviously, on the opposite side, of the manufacturing industry, in case of building industry, the main waste is due usually to errors, not necessarily to a lack of efficiency. So which means that, for example, a worker on a construction site is able to do efficiently his task. But anyway, maybe it make mistakes because it doesn't know what exactly has to do, or maybe doesn't have complete information when he has to execute his task, for example. So applying lean methods to the building industry means also changing the way we are identifying value. So some of the speakers before me correctly underlined that the value stream mapping, for example, it's a very powerful tool to identify the value, or to identify the value, or somehow to map the processes as a whole. But on the other hand, usually this method has been applied in manufacturing industry, where obviously the most important step is the material flow, because it's generating value, because the final client, the final customer will pay you for the final product, the physical product, not for the business processes that are supporting, for example, these material flow processes, these material processes. So it's important to understand that design, engineering of the product, because you have to start them once again, every time that any order is delivered, has to be absolutely included in this evaluation. So this approach works for manufacturing industry. I mean, looking at the pure lean construction and the pure lean methods, as other speakers said, but they cannot be applied one-to-one in the building industry. So talking about errors, which are the main, let me say, the main cause of wastes in the building industry, we can say that error can be generated by human themselves or by processes. They are dependent by processes somehow. So what does it mean? It means that a human can generate a wrong information. On the other hand, due to maybe a very complex process, or let me say somehow due to a miscommunication, you can obviously miss some key information that has to be obviously delivered for executing a task. So if we try to look at the solution that are offered by the scientific community for this aspect, obviously personal skills is just, let me say, wrong information or error generated by human are problems of personal skills. So we cannot solve anything in that case. So people have to learn, have to, let me say, update themselves, as you as participants are doing today. On the other hand, when we have missing information, we have to change the process structure. So maybe applying what is called front-end strategy, so which means anticipate as much as possible. On the other hand, maybe the communication can be solved using or applying different information systems that can unify, that can share a common language, as for example the value stream mapping is in lean methods. So obviously the front-end strategy relies on tools or on approaches on strategy that somehow require that every possible problem have to be defined and solved when it's possible to control costs, which means that if I'm, for example, I'm installing a wrong door that is not accessible for a machinery afterwards during, for example, building maintenance, obviously when I have to change this door and the building is already constructed, it costs a lot more than not changing some drawings at the beginning of the process, when I can, obviously it doesn't cost anything because it's just a matter of changing an information. It's not a matter of changing a physical object that has already been constructed, for example. And on the other hand, if we talk about information and the information system, the problem is usually that building industry until today is relying on blueprints, on drawings, you know. And drawings are not somehow a digital information or somehow, let me say, a smart information, because this kind of information should be understood by human being. So which means that cannot be delivered, like cannot be translated one-to-one in a task, but a human being has to somehow look at the drawing, understand it, and translate this drawing in tasks. And this can generate misunderstanding, as you can understand, as you can imagine. So an engineer, an electrical engineer, is looking at drawings in a different way than an architect, than a structural engineer, that I don't know, an HVAC system engineers. So let me say that introducing a common information system means moving, let me say, the building industry towards a complete and comprehensive description of the object, which is, in other words, the product, or in other words, once again, it is the building itself, because it's the final product of the building industry. So from this point of view, the solution is simple, combining front-end strategies with digital information systems. But anyway, we are talking about physical products, which are buildings, not digital one. We are not talking about software, about data that are in the cloud, for example. So a physical product that has to interact with unpredictable boundary conditions, as we discussed earlier. So we have to start from the physical world and return once again to the physical world through the digital one. So we have to start. And let me say, the first question that I have in mind is how to collect efficiently information from the real world.
Thank you, Gabriele. Despite technology have advanced a lot in the last year, one of the biggest challenges for implementing robotics in construction is, in fact, to provide accurate and up-to-date information on the real buildings and on the real stage of the progress of the construction site. So there is the need to find a compromise on the accuracy of the data, the optimization of the processes, and the reliability of the information. In fact, in construction phase, there are 4 types of data acquisition needs that are related to positioning, to tracking, progress monitoring, and quality control. And each one of these requires different levels of precision and accuracy. Even though the technology is very precise, in some tasks in construction site, such amount of data is not necessary. So it's up to us the decision on how to use efficiently the technology. In fact, point cloud and BIM can deliver a lot of information, but all this data have to be managed, filtered, and transformed in order to automate the communication among workers, machines, system, software, and robot. In this context, I would like to present the project of Fraunhofer Italia, the Auto Build Check for autonomous as-built check, in which the scanning technology is mounted on a robot, and it used for the 3D for the check of the 3D model against the real-world situation. And a fast comparison between the scan data and the real world and the BIM model can help in improve the early detection of error in construction site and can help in saving time and costs. Yes. Another project of Fraunhofer Italia is the Field2BIM, that is also a software that aims to that is used for the semi-automate passage and data transfer from the real world and the digital one, in particular for the transfer of the laser scanning data and the digital model, in order to generate a BIM model using machine learning and artificial intelligence. In this software, a room recognition tool has been developed together a semantic segmentation of the cloud that can help us in classifying the elements of the building And this data will be then used to develop the building, the BIM object and BIM model, so to improve also the level of precision of the information. And in order to for construction to become more automated, we have understood that reliable acquisition and data transmission is very important between sensor systems and people. And so the question, a key question is, how can we transform this data efficiently?
Well, Cynthia, to understand this question, I think that we have to somehow explore and understand once again the evolution of the digital information system within the building industry. So we mentioned earlier that the building industry is led by drawings, by blueprints, which somehow are a kind of descriptive method. So which means that information content obviously is limited by a geometrical description of the object. You can add some notes, for example, on the side, but anyway, it's just the description of the geometry itself of the element or of the object that you are transmitting within your information. The evolution of this approach is the parametric model, which, let me say, metadata, in where metadata enhances the geometrical information, so applying somehow parametric object description, so which means that I can describe the building through pillars, to walls, to floors, and so on. And obviously, each of them can have some metadata. So you have the geometry, but on the other end, you have a bunch of information that can contain, for example, energy performances, mechanical performances of this element, material density, physical properties, whatever. And obviously, and this is somehow what today we are living. So the transformation from something that is descriptive to something that is more somehow parametric. And the next future is to move from parametric modeling to a procedural method, which implies the use of computational methods. So the object is not only described using parameters, but is using by somehow is described through a network of logic relationship between parameters, for example, that have to generate a solution to a design problem, which is completely different. So we are not just moving the information of the final solution, let me say, of what we are designing, of what we are engineering, but we are moving also the process, let me say, that we applied to generate that solution to a design problem. So it's a completely change, once again, of the paradigm. So building information modeling is introducing somehow a common ontology and a common semantic in the information system, which is something that is missing right today. So if you think, and we can make a comparison with, let me say, within the information technologies science, where every one of us, unfortunately, and let me say unfortunately, commits this kind of mistake that considering the PDF file a digital data. A PDF file is not digital data. The PDF file is a digital format, which doesn't necessarily mean that it's also digital data, because as the drawing, this data, or let me say this format, has to be read by a human being and has to be translated somehow by a human being. But a computer, a machinery, cannot understand a PDF because cannot read, because it doesn't know the grammar, it doesn't know the language, it doesn't know the ontology and the syntax behind what is written inside the PDF file. So here is the same. Building information modeling is introducing these changes, so it's somehow standardized and establish some rules about ontology and semantics. So this can enhance collaboration and somehow facilitate, obviously, front-end strategies. So which means that everyone can cooperate in a unique environment, in a common environment, and at the same time, this can be a human being or even a machinery. But anyway, a parametric description as it is in building information modeling, and we may lead towards a strong standardization because we are describing the building through walls, through pillars, but not every time we are talking about pillars or we are talking about walls. So let me say that building information modeling cannot handle easily complexity or extreme customization of the final product. So according to this perspective, building information modeling should be intended as a standard methodology to manage, to store, and to share information. But in other words, it's just a relational database somehow that uses 3D modeling of a building, let me say, to structure the data. But if we think about, computational tools that we discussed earlier, these tools can overcome these limits because they are focusing on the generation of the information instead of its management as the building information modeling. So let me introduce some examples. And let me start somehow from something that is, let me say, a kind of best practice example. So this is the Sagrada Familia. I think that every one of you knows which building it is. It's obviously located in Barcelona. It's a huge cathedral and is the masterpiece of Antoni Gaudí. And somehow, let me say that his mind generated this huge and fantastic idea to create this cathedral using geometric complexities like, for example, ellipsoid and paraboloids. But these kind of geometries cannot be handled easily because if you start dividing these geometries, you can find that every element is different from the other. I mean, at least row by row, for example. In order to solve this complexity, they, in the years, and to speed up the construction of this and the finishing of this amazing building, they decided to move towards an off-site prefabrication, applying digital tools, for example, until design phase, applying CNC machinery on an off-site prefabrication site, as you can see, and afterwards using also the participation of human beings, somehow customizing and creating unique elements that afterwards that has to be assembled on site. If you think you are in the middle of a huge city like Barcelona, so it's not easy to prepare a construction site that can host a lot of people and, let me say, waste a lot of space. So they have to absolutely also for necessity adopt this solution. And as you can see in this case, they could boost the construction of this building a lot in the last years. So probably, I don't know the latest updates because obviously due to coronavirus emergency, maybe something was changed in the past, but they somehow foresee to close the construction site at the end of 2026 when they started, because if we look at the documentation, Antoni Gaudí started at the beginning of the last century. So which means that in the last 30 years, they are doing what Antoni Gaudí and his successors, so what has done, for example, until the 80s and the 90s, they cannot do, obviously. So we are doing in the last 30 years what cannot be done in the previous 90s. So on the other hand, obviously, even in our research activities, we are applying computational tools to increase, for example, the sustainability, the variability, and the performances, even of highly standardized building products or building elements, such as glued laminated timber. So we try to understand how we can apply these techniques also, let me say, in an industrial environment that is producing somehow standardized products. And we applied the value stream mapping as mentioned before, we applied this technique to identify the flow and analyze somehow the impact on the standard production system. And somehow we recorded that it's possible to increase the variability of the product, even reaching almost mass customization. So which means lot size 1, which means that every product is different from the other. So in that specific case study, we obviously analyzed one of the biggest producer of fluid laminated timber here in Italy. And in order to, let me say, respect their delivery plan, actually they are producing just 3 variants per order. So 3 products variants per order. But applying, for example, computational design techniques and this digital tool, is it possible to boost this, let me say, and to speed up the process of preparing the information for the production flow, and somehow even reaching the lot size 1. So which means that is almost the maximum complexity that this production line can handle. But on the other hand, we also recorded that no upgrades, any upgrades are required to the production line. So except for example, the intralogistics, which means that obviously only the loading machine has to be changed because it has to manage, let me say, a higher variability of the raw material. And now, this somehow this task is performed manually by an operator that is, is moving the material from the warehouse, for example, to the production line using, simple lifting machine. So maybe in this case we can re-engineering only this part without changing the production system itself, without changing how they are producing the glued laminating timber right now. So without, for example, firing anyone, because that everyone is scared that robots can somehow take place of human being, but it's not like so. It's not like that. So in that case, you keep the production line exactly as it is. And so these results highlight that likewise in Industry 4.0 framework, physical and digital worlds have to continuously exchange information to reach this, let me say, most effective compromise between that antagonist goals of industrial approach that I mentioned at the beginning of our presentation. So, talking about Industry 4.0 framework, we are missing just one step. Do you remember? We have to start from the real world, going through the digital one, and afterwards going back to the real world once again. So, we are missing how to return digital information to the real world, or to human beings, or even to machinery and robots. So how we can do this task, how we can return information on construction sites, for example.
Thank you, Gabriele. In fact, construction has always to face the installation phase on site. So the first problem is how to get information to construction site, because standardization and automation are difficult to achieve without digital tools and digitized processes. And regarding processes, this tool developed by Fraunhofer Italia, the Bean2Fill tool, aims to support the manager in the management of the digital management of the construction site. It is based on the methodologies for optimizing the human task, such as lean construction and Kanban and digital Kanban board. And using the last planner system, it provides the relevant information directly to the site workers, so to efficiently have the information you need when you need. From construction point of view, from construction site, construction is increasing its level of digitization with the use of building information modeling. And actually, in fact, some of the robotic technologies are BIM-based. the following example, for example, the Dusty robot, that is a beam-based robot that prints out full-size floor plans directly on the construction site. The Boston Dynamic Spot, that is for a fully automated inspection of hazardous environment. The Kevaso Liftbot, that is an assistant for the assembly and disassembly of scaffolding, and the J-Bot, that is a drilling robot based on BIM model. Then, from robotic point of view, ROS is one of the most common and open source operating system. So within the ROS BIM project, Fraunhofer Italia aims to improve the site logistic using a robotic platform with an autonomous driving based on ROS. For doing this, a new node to link ROS and BIM have been developed using IFC file. And now it is possible to generate time-dependent maps based on the project scheduling. So the robot, while operating, can adjust its path, knowing the information inserted in the BIM model, and also with the obstacle detection. So it can support the workers in carrying material from one place to another in the construction site in safety. One step forward is the Balto project. Balto is the name of the disinfection robot. This robot can disinfect doors or other objects within a complex building. It works autonomously thanks to the direct link to the BIM model and reacting in real time to the human beings in the surrounding. And finally, I will present the last project of Fraunhofer Italia, that is, no, sorry. One step. No. There is a slide missing, I think. So the last project was CONCERT. It is the last project funded by the program Horizon 2020, and it aims to develop a new concept of industrial robot for construction site. And it will be versatile, and it will be composed by assemblable modules. So the worker can define the final configuration in order to best support him for the task he has to carry out. And from my side, it's all. And thank you for your attention. And I think the presentation is finished. Thank you a lot.
Thank you, Cinzia.
Good evening to everyone. So we came now to the second Q&A session that we try to moderate. So don't be shy, write down your question on the question box so that we can answer that. So we have a first question for the team about the digitalization. So it was said that not all the big amount of data are useful and are necessary to use only the useful data. The question is, do you use AI tools to choose the data that are useful to be treated?
For me, Gabriele would.
It's up to you to answer.
Hey, Cynthia.
Okay. I think that at the moment, the technologies use every data that can be delivered from the LiDAR or other technologies or other sensing technologies. But I think that in future we can develop the other system to choose which is the best level of accuracy and needed for each task. So like for the last example of a robot in which the worker can define the best configuration of the robot, I think you can in future you can decide also which is the level of the sensor you can you need to perform each task you have to carry out.
Yeah, maybe Cinzia, also let me add that the problem is always the same. So accuracy versus precision. So it depends on the task. So the problem is that usually you have to analyze the information that you need according to the task that you have to accomplish. So for example, specific tasks require accuracy, but doesn't require precision. So if I need, for example, to measure, I don't know, the status of a construction, I don't need precision. Maybe I just need accuracy. So I need just to know if a wall has been constructed or not, but not to know exactly the position of the wall, for example. For other tasks, for example, if I want to apply a machinery, a robot, or I don't know, anything that can support me, you know, placing an object in position, in that case, it's absolutely important to have also precision. So which means that the measure should be precise and, let me say, delivered at the moment and when exactly and to who exactly needs that information. So from this point of view, it's very complicated to say that there is a methodology to choose it. I think that somehow this kind of information should be analyzed task by task. And in this case, maybe value stream mapping could be very, very useful, because you can use value stream mapping applying the same somehow techniques or approaches that you use for the material flow, also for the information and for the business flow. So maybe analyzing which are producing the information and where the information is transmitted or to whom is transmitted that information. And in this case, maybe it's also you can go, you know, in this iterative way of applying the lean methods, maybe going deeper and deeper and deeper in details and understand exactly which kind of accuracy and which kind of precision, for example, you need for each subject in the task, for example.
Thank you so much. Let's move to the next one. How do the lean methods support your research activities in the digital transformation of the building industry?
So as you saw during the presentation, somehow we are applying lean methods to understand better the flow of processes. Because as you can see, as also previous speakers underlined, value stream mapping is a very useful tool to have a common language in describing processes. So even for us that we are technicians, we are working with this kind of machinery that probably are not so addicted to lean methods and so on. But anyway, also for us, it's important to have a common language and a common understanding of the process flow along a value chain system. So according to this, we are using this kind of techniques, especially for evaluating solution or evaluating application of digital tools, like a kind of, let me say, method to measure results. And especially the value stream mapping is very, very useful because it can be used also for simulating the application. So as soon as you have the real value stream mapping of the real value chain system, maybe you can apply modification and you can apply evaluation and looking what is going to change among the entire process and looking if it works without, on the other end, modifying the daily activities that are performed in the real world. So it's very, very useful for us and very, very, let me say, important in our activities.
Thank you so much. So go to the next one. If you would rank the benefits of using BIM, what are the top 3 advantages?
Cinzia, would you like to start?
I think it is, like Gabriele said before, it is a database, a comprehensive database of all the information of the building. Another important factor is that the file can be shared with all the stakeholders, and so we are talking about the one thing and the unique thing, and so there is not a misunderstanding on what we are talking about. And I don't know, I think it's saving time also for when the BIM is implemented in the enterprises, not in the first stage, because it takes time to understand this new method and this new type of design.
Thank you very much.
Yeah, I do agree completely with you, Cinzia, but I would like also to underline something that also the previous speaker underlined, which is that it's not digital tools, or let me say, it's not the digital tools that defines the process. So one of the, let me say, common mistake that is made by every entrepreneur is that, okay, I have to do everything in BIM, so I will buy BIM. But buying something is not the solution. So it's not like you need a machinery and you buy the machinery, full stop. Even if you are somehow manufacturing industry and you are introducing a new machinery, you have to plan this introduction. So which means that somehow you have to elaborate a strategy, because you have to stop something, to stop some task in your company, to, for example, introduce a new machinery. And at the same time, you have maybe to somehow train your workers to use this new machinery. And with building information modeling, it's almost the same. So the important thing that you start, let me say, working with digital tools somehow in a very critical way, and look at them in a very critical way. So it's not just a matter of saying, okay, it works, but on the other end, it's just a way to say, I don't have to change my daily workflow to adapt it to a digital tool. It's exactly the opposite. It's the digital tool that has to be adapted somehow to my daily workflow. And on the other end, the daily workflow, it's always different. So from company to company, from, let me say, from worker to worker, because it's somehow something that has been grown with experience year by year, doing the same task, or let me say, delivering the same product. So it's very complicated to change, let me say, this point of view. And the important thing is that you look at the BIM as an opportunity, and you have to introduce it as an opportunity, not as something that has to be done because my competitor is doing it or because it's requested by the law. So that's the most important aspect.
Thank you. So going to the next one. Each new technology follows a general development cycle, from research and development to early adoption to later mass adoption. Where is the construction robotics in this cycle at this moment?
Okay, I think that robotic technologies it's not new, because we all know that researchers and scientists have been studied since the 60s. However, in the last 10-20 years, there were a lot of investment and a lot of new improvement in research and in testing. And I think that today we are still on a prototype and test stage, I think. However, there are a lot of robotic technologies on market, but I think that in coming year most of the construction enterprises will start adopting these technologies and using these in their daily life and daily business. So I think that is today a prototype, but in future they will use more frequently.
Thank you so much. Thank you, Cinzia. Thank you, Gabriele. I think our time is finished, so we could move to the next session, right, Stefano?
Yes. Thank you, Matteo, Gabriele, Cinzia, and everyone that asked questions this session. I'm going right now to introduce you the last speech of today held by Ben Breen. Ben Breen is Managing Director Asia Pacific and Head of Global Construction for PMI Global. Unfortunately, due to the time zone, Ben will not be able to be here today because it's 1 a.m. now in Singapore, so it will be unbearable. So he sent us a video with his speech, of course, and made himself disponible to answer questions via email. So if you might want to write him email to ask any question after his speech, you can write to ben.breen@pmi.org. You can easily find also in the pmi.org website. If you write to him, please specify that the question comes from this webinar, so he will know. Right? So I ask Francesco to launch this video and enjoy it. See you later.
Hello, my name's Ben Breen and I'm the Global Head of Construction for PMI. I'm really excited to be here today to talk about the construction initiative that PMI has undertaken. And we did that about a year and a half ago when one of our partners came to us and said, we have thousands of people who are undertaking the PMP course, which is fantastic, but is there something specifically that can be developed for the construction industry? So we started to do a bit of research and speak to other partners, and we definitely saw that there was a need in the industry for this to be developed. So we decided to bring together some wonderful minds in the industry. We started talking about what the pain points were in construction, and we found that actually they were the same sort of issues all around the world. So PMI and our partners have decided to do something about that. So we embarked on this journey and we have looked at creating a construction industry course, and the PMI vision is, as you can see here, to transform the construction industry by making it more efficient and sustainable. The second vision was to partner with the world's leading construction experts. So we brought people from all around the world, from all different parts of the built environment, if you like, from developers, contractors, consultants, etc., to make sure that this was an industry-led initiative. And we also wanted to create a global industry forum. So that was getting together with brilliant minds, talking about the construction industry, you know, what is the future, how can we navigate our way through the difficulties, and just getting together to teach and learn from each other. So in order to achieve that vision, we wanted to do a little bit of research and determine, you know, what is the landscape out there at the moment. We started to talk to about 40,000 PMPs in the construction industry, and we wanted to cast the net even wider and make sure that we had people from, you know, not familiar with PMI, as well as those who are very familiar. And we then did a lot of surveys, a lot of interviews over a 6-month period of time. So what we found from that research is things like 72% of projects are delayed, 70% experience some sort of scope creep, and 73% end up over budget. So they were pretty scary numbers. And our Pulse of the Profession survey from 2020 determined that for every $1 billion spent, there was $127 million wasted. So that was a huge number. We definitely looked at that, and that validated our need to try to do something about that. So our research, as I said, went to a lot of people, and we wanted to find out what was the subject matter that was relevant to them, to either them as an individual or to their team. So what we found is, surprisingly, number one was the scope triangle, a very fundamental thing in project management. But there was others like scope and change order management. There was communication kept coming up again and again. And I suppose that's really no surprise. And there was others such as contract process, health and safety, etc. So we were starting to gather that level of information. We also wanted to understand what are the most important skills for you in your role today. So again, the top three there were leadership with 35%, communication again jumped in there, and that was at 31%, and then cost control as well at 27%. So we were starting to understand what people were saying in the industry. We then wanted to understand the overall construction landscape. So obviously, in the past 18 months, the effect of COVID-19 has been absolutely enormous. It's really changed the way that we operate in this world, but also how construction projects are run and the types of projects that are being undertaken. So first of all, we can see that projects in hospitality, retail, entertainment, etc., they were not as likely to be proceeding, certainly not to the extent that they were previously proceeding in. But projects like infrastructure, transportation, and healthcare were really going to be growing exponentially. And you can see that from the government stimulus as well, in terms of whether it's the Biden administration with the trillions of dollars that are going into infrastructure. We're seeing it in Australia, Japan, etc. So this is happening all around the world. And it's really to stimulate the economies, to make sure that people are gainfully employed. The second one was on worker safety. So this has always been of paramount concern. There's always been a lot of attention paid to it. And even more so now with COVID. We had to look at off-site construction methods and minimizing the amount of time spent on site, but also the amount of people that were on site to put things together. The third one was virtual meetings. So new tools have come in, just like we're doing right now. We're able to virtually meet and collaborate. And in fact, that even brought some advantages, because people were able to dial in from all around the world and provide their expertise, whereas previously you would have been restricted to just having somebody sitting in the meeting room on the construction site with you. And the fourth one here is that the modularization and prefabrication, so it's in line with that second point there. And this was about cost savings, because now budgets were being scrutinized even more highly, and shortening the schedules, because it's taking longer to get things done. So we need to come up with other innovative ways to make sure that we're reducing the timeframes. The next one is on the supply network, or the efficient use of resources, making sure that we're sourcing for products that are locally available, or reducing the logistics of getting them to the site. Robots, automation, things like automatic bricklaying or drones for inspection. We have one of our big partners who has one room just full of young drone operators who are sitting there monitoring the pipelines or doing a facade inspection and all these amazing things. Artificial intelligence is helping us to make the work environment even safer, tracking workers to prevent accidents. But it's also being used for things like augmented reality, so that one person can guide another person on the other side of the world through a complex task and do that in a safer way. So technology, there's no doubt, prior to COVID, it was already disrupting the industry. It has had a very large impact over the years. And in fact, studies by McKinsey show that in the next 10 years, 400 to 800 million people will be displaced in the roles that they play, and they'll need to upskill and do something different to survive. So here is, some of the data that we were able to gather. 18% of people are using mobile apps on the projects to collaborate. 63% are using drones, which I thought was actually a relatively high number. 37% expect to adopt equipment tagging. 33% expect to use wearable technology, such as myself. It's certainly helped my golf game, that's for sure. But that's becoming more and more normal in construction around the world. And about 75% of people use cloud storage to collaborate. So that's also become very much a norm in the industry. So we are gathering a lot more data. It's being gathered from all different sources nowadays, whether that be with sensors or online collaborative systems or whatever it is. But the problem is 95% of all data captured is not being used. So that's a concern. We need to make sure that we're effectively using that data to get better at what we do. It was also obvious that 60% of companies do not have a dedicated R&D budget, and particularly in the small and medium-sized companies, they really just don't have the time or the budgets to do something outside of running a project. So if you're introducing something on those sort of projects, you're doing it on the fly and you're trying to get it right. So it's difficult to do that. About 59% of the workforce don't have the skills to use BIM. And BIM is a wonderful technology that's used extensively all around the world. But it has been around for 50 years. It's not exactly a new technology. And yet 40% of the workforce still don't know how to use it. This is a very scary statistic. 19% of projects in the UK are still paper-based. Amazing. And 38% said there is a lack of staff to support the technology. So that goes back to that R&D budget as well. There's just not enough people and money to run these sort of research and development projects that need to be undertaken. So to paint the picture further, we partnered with McKinsey as well and looked at their findings on construction. The construction industry is in fact the largest in the world. It makes up 13% of GDP. And the fact is, it's just not performing well. It's grown at a very, very slow rate for the last 20 years, in fact. But more recently, so in 2019, private equity firms raised $100 billion just to fund infrastructure projects. And that, in fact, was pre-COVID. So that's going to get even higher. And nearly $70 trillion in global infrastructure investment is needed through to 2035, just to keep pace with what's going on all around the world in the built environment. This has become a very major issue, skilled labor shortages. Look, we have been speaking to a lot of companies, and this has become the number one issue, attracting and retaining talent. In a lot of countries, it's been difficult to even get the talent to fly in to solve a problem, and particularly in some of the remote locations. And you can also see here in the US, 41% of construction workers or the workforce is expected to retire in the next 10 years. So that problem is only going to get larger. Construction projects have become a lot more complex, with an increasingly large amount of them over $1 billion. So, that's what we consider to be the mega projects. But we also found that companies that can adjust their ways of working, that can understand what's happening and pivot quickly and be what we call gymnastic, change the way that they're working, they can do very, very well through this crisis, while others that really are not prepared to change or are too rooted in their ways and are unable to make those changes will fall by the wayside. So that's it in terms of the landscape. We've determined the vision of what we're trying to achieve. We've looked at the landscape and why we should be playing in this area. It was really important to understand from our customers' perspective, how is this going to help them? So that's the construction initiative that we've undertaken. So we have put together what we call the expert panel, and they are made up from industry leaders all around the world, be it developers, contractors, consultants, all of these companies working throughout the built environment. Some large names that you can see here. We had Saudi Aramco as one of our initial companies that came to us that I mentioned at the beginning. We've got companies like DPR Construction, BHP, etc. And Lean Construction Institute and the Construction Industry Institute are two other not-for-profit partners similar to PMI who have really helped to bring this very professional course together as a whole. So we're very excited about that. We, as I mentioned earlier as well, we wanted to set up this global industry forum, and that was just making sure that we were bringing not just those expert panel members, but opening that up to a much larger audience to get together regularly, to network, to talk about the future of construction and collaborate and come up with some wonderful ways of navigating through this very turbulent world. So that's something that's in progress, and we look forward to getting everybody involved in that sort of initiative. So we then have landed on our, let's say, our draft course syllabus, and I'm not going to run through everything here. There's a lot of detail here. But if you look at this, for example, we have the first course on effective project communication, because that was voted in as being, one of the top 3 things that we needed to resolve. We wanted to look at the pain points initially, then talk about the learning objectives, look at the learning outcomes that we wanted to achieve. So we've done that for each of the different courses that we're looking to develop. We've also determined there's certain micro-credentials so that at the end of this course, you're able to do that micro-credential and get a badge. So the second one was scope and change order management. The third one was interface management. The fourth is performance management. The fifth is execution planning, and that also came up as a really critical element that we needed to focus on. We've also labeled that with a micro-credential. And the 6th and 7th are contract and risk management, which is always important in any project that we're running. And a new one is technology and innovation, which has also been earmarked as a micro-credential because of the focus that our members put on this in saying, how can we get better at introducing technology into our construction projects? So we have already launched some of those courses. We've been doing testing and getting feedback for some time now, and I was really encouraged to see the high level of customer satisfaction, agreement that the content is relevant to the job that they do. They're likely to recommend to colleagues. They agree that the learning is visually appealing, so we really wanted to create an e-learning, online, self-paced course so that people can take a short break from what they're doing to spend half an hour, whatever it is, so that they can get online and improve their skills. And also an agreement that there are learning takeaways from this. So, as I mentioned, 7 online courses. It's called PMI Professional in Built Environment Projects. And you can enroll now. So you can go to our website. You can look at the new courses that we have, and you'll see those 2 in terms of the Built Environment Project Communication Pro and the Scope and Change Order Management. The second one is still in a beta phase, and we would love people to get involved to help us improve the subsequent courses. And as we said, we really want this to be industry-led. So finally, we are looking to transform the built environment. We're looking to do that by reducing cost overruns, by delivering better outcomes, by increasing productivity and competency of practitioners, and ensuring continuous development of the talent pool. So thank you very much. It's been my pleasure to talk to you about this initiative, and I hope that you're just as excited as we are. And I'm sure that this will be able to bring you some wonderful benefits to you as an individual or as an organization. Thank you.
Right. Thank you. If you might want to see again this event as a whole or a part of it, you will find it soon on our YouTube channel, the PMI Northern Italy chapter channel. Okay, now if you have registered with your PMI ID number, PDU, you will receive it automatically, as you can see. All right. The slide, as I told you, will be available on our website. All right. If you need any kind of information, please write to us via events@pmi-nic.org. All right. Now let's go to the poll and see how. Please, you might know how it works. Please go to www.menti.com and use this code to our survey. We're really looking forward to know how you find our event. And so please give us some feedback and we will use it. For example, the case studies today presented by Luca come from a suggestion from the previous events. So again, we are really looking forward to know any suggestion, anything you can give us to improve us in our further initiative. Right, some answers are coming. All right, give you some time, of course, to answer. Right. It seems we've been pretty good. Okay, the satisfaction survey can go on. Now I'm really happy to pass the microphone to the president of PMI Northern Italy chapter, Giusy Meloni. Giusy?
Yes. Hello. Hello, everybody. Can you see me? I'm sorry, it's very dark. I thought it would be a little bit better. Let me turn the light on. I'll be right back.
Yeah.
I couldn't check the light because you had the video on. Oh, there it is. Here I am. Hello. Hello, everybody. Hello. Just a few minutes is late, and you've been following the presentation for all afternoon, so I guess you're all tired. I just wanted to use these opportunities to say hello to begin with. And to this particular event, because it has a strong significance, I believe, for our association and our profession as well. This event, of course, organized by volunteers, and let me thank them again. I know that they've done a wonderful job, and in this particular case, the event was organized to have a global reach, to go beyond frontiers, to hear different voices. And this is not only PMI wide, so we had Ben, for example, is also among chapters. There was a strong collaboration among the chapters with other chapters. And that's, I believe, part of probably the best part, personally, what I consider the best part of our profession. The possibility to go beyond frontiers, beyond borders, to consider knowledge and opportunities wherever the best can be taken. And that's also the best we can get from our association, from our community. I must confess, I don't know anything about link construction and digital tools. Digital tools a little bit, but not for link construction. All the same, I had to join late, but I was able to listen to the last few presentations. And once again, it's the knowledge, the sharing of the knowledge between people across communities, across sectors, across chapters and countries that makes the difference in our community. I don't think I have much more to say. So if not, again, thank you to all the people that participated actively. Thank you for the feedback. I was here and just saw that the feedback is rather good. We do consider the feedback a very important part of the process in everything that we do. A very important part of the relationship that we try to keep with our members and with other communities of members and PMI. So please, we will take care of it, we will consider it, but please do never hesitate to get in touch with us to let us know what you will find interested, or what you didn't like even, and how can we do better. My last word again is thank you to Stefano and to all the volunteers, and thank you, a special thank to Silvia and Francesco as a branch directors who join hand for this wonderful event. And with this, just have a nice evening, everybody.
Thank you, Giusy. Thank you very much for your words. Well, here the event ends. I hope you enjoyed and you find it useful for your profession. Let me say, from my point of view, I really appreciated in the presentation of our speakers the priority given to the methodology and the process over the digital tools, which most of the time today they appear as the solution of everything, but they're not. We know they're really useful and sometimes necessary to reach the results, deliverables for we project manager. But we always have to bear in mind that the aim of our work is not to use the latest sophisticated tools. This is not. But is instead create value using the best methodologies and tools applicable to the specific situation. This is our job so far. I kindly ask to all speakers and volunteers to switch on the camera for the final greets. I would like to thank again our sponsor, Clima Center, Fraunhofer Italia for their scientific patronage, and the Ordine degli Ingegneri di Gorizia for their patronage. Many thanks to our available speakers, here they are, and to all the PMI's volunteers, let me rename again, Silvia, Francesco, Matteo, Fabio, Rastin, Wisla. Without your support, we could not have accomplished all of this. Thank you very much again to all you for your attention and very interesting questions. Have a nice evening and see you soon. Ciao.